This is the chi-square test for independence, 4-step generic. This is 4-step number 12, I think. And we are in chapter 11. I think I'm right with this being number 12. What do we often, there's one of two things that we always write in state first, which we kind of switch back and forth depending on how we write it. What are the two things we write a lot? We define what two things? Say it again. Population and parameter. So this one, our parameters are like categories, so we don't really need to define those, but we do still need to define our population. Population, then we try to find in context. We are doing a test, which means we need what? Null and alternative hypotheses. So our null hypothesis, which we've already talked about, is going to be what? The column variable and row variable, and you actually fill in what they are in context. So our null hypothesis, we are starting initially with the fact that we're assuming that they are independent. We are checking to see if there is evidence that there is a connection or a relationship, which means they are not independent. So alternative hypothesis is everything the exact same except not independent. And again, I always just out of habit write capitalized not, just kind of to myself knowing which one's which. And then it still is a test, which means we usually go ahead and define or talk about what in our state. And same rules apply with alpha. It's just a number. If one's not given, we're using 0.05. All right, so plan, what's our first part of plan? Well, our method is as straightforward as we can be. What kind of test are we doing? Chi-square, a chi-square test of what? Independence. Sometimes I write some, sometimes I write 4. I don't really care about that part. So I've done my method, then I go into checking what. And just like before, I don't care if you write check conditions and you want to separate it that way or not. That's up to you. Our first condition you just said is random. I'm not going to write anything there right now. Beside that, it's the same way we always do. I might get more specific about it and come back tomorrow and write something different, but I mean, random is checked the same way random always is. So it's usually random than normal, but what if we said we're going to use what instead of normal? Which is essentially the same thing. So we made 3 charts when we did our example for the notes. There was a given chart, the first chart we made, and the second chart we made. So where are our expected counts? The first, second, or third? The second. So usually I'm doing this like as a problem. So usually I would just go ahead and here make my expected counts chart, but somehow write something that's like expected counts chart. If you have it on a separate sheet of paper, you would just write like on other sheet or something. But you would need to specify, like you don't want to make the grader guess which chart you're talking about. So you can label it expected counts chart or something. But what we're actually checking for is that all expected counts what? So like I said, that's still technically kind of checking the normal conditions. Chi-square distribution is not normal, and that's why we don't call it a normal condition that we're checking. And then our last one is what? So independent 10% condition, nothing changes about that the way we've been doing it. And then there are at least however many. Talking ahead, this test is going to be next Monday. There are no quizzes left that are regular quizzes. This test is next Monday. The last regular test is, we don't know yet. Probably going to be that Friday, maybe that next Monday. Probably the next Monday. So technically your last two tests, one of them's in a week from today, and the second one's in a week after that. And then we go to do. Chi-squared is going to be like adding all of them up. So I just out of habit do degrees of freedom first because it's something I can calculate before writing everything out. It doesn't actually matter if you write it out first or not. How do we find degrees of freedom for chi-squared? And then that'll give us some number. And then so we actually have to figure out our chi-square value. So if I wanted to figure out my chi-square value, it's easier for me to just talk through it because you have both charts in front of you. If I wanted to figure out, like I know that my chi-square value for high current is 4.5838. How did I come up with that number? I talking my numbers. I did 51 what? Minus the 68 number and did that squared divided by the 68 number. So what I'm basically going to do, and don't write this yet because I don't want you to write real numbers in there, is me saying but I would have to write this for 9 different values. So for me to say I'm doing this for every single one, I could do this and then go all the way to the very last one, where the very last one would be whatever, go with me. So we're actually just going to write the first number and the last number, and that's me showing, hey, I'm doing the same process for all of them. But it's kind of hard to write that out generically of where these numbers are coming from. So if you're good with what I wrote, that's fine. Just if some people want more stuff, those values are expected. This is all the last value. This is all the first. I'm doing that more for the video than anything else, so that if anybody needs to go back and see it. But when we write it with an example, it'll make a lot more sense. So our chi-squared, so once we found our test statistic value in a 4-step process, what is my next step now? Where do I show somebody I know what this is doing and where? What's my next step? Drawing and shading it? Well, a chi-square is a right skewed distribution, but we're still going to do the exact same thing and draw and shade it. So this actually starts at, and don't draw this, this starts at 0, so chi-square values are all positive. So we didn't get a total yet. So you're always going to do a line and then shaded right. But for now, I just want you to write draw and shade. Once I use this, draw it, shade it, find it, I find my what? What? I get my, like, so this is like a Z or a T. I look it up in the chart, or I look it up in my calculator, and I find my what? P-value, my area, my P-value. So this process is the exact same. I compare that to my what? And I decide if it is less than or not less than. So all that is all the exact same still. So conclude. How do we start conclude? Because it's a test. What are we rejecting or failing to reject? And now I'm actually just going to write null hypothesis and not write the whole thing out because because my next sentence is going to be writing out the whole alternative, which is the opposite of that. So we can kind of make our way around it for this one. So we failed to reject null hypothesis. Why? Which means that we and then we're just rewriting our alternative here. So column variable and row variable what it's going to go after that because I'm writing, am I writing the null or alternative? Alternative, so I write that they are what? And that's, again, a lot of why I do that capital is because, like, I'm making sure I write the right one right here. And I'm making sure that people who are following my notes and remember which is what. Oh, I usually, recently I don't have to write it. Who am I saying that we do or do not have evidence for? That's a bad question. Recently, I haven't needed to add that in. Why? Like when I do proportions, I don't need to write that it's for that population. Why? Because where do I actually define population when I define proportions? Within the parameter itself. So it's already defined in the wording, but we never defined it within connected to the variables. So we still have to write specifically for this population. Alright, so now I'm gonna go real quick for the important part.